Welcome to the good ship Halo. As you can see, it is an absolute bomb site at the moment. We are halfway through doing a bunch of electrical work, and we have decided to put that on hold for a couple of days as we install our brand new Watermaker, which is an Oceanflo OF70. So I'm here with John. John, do you want to talk through some of the parts involved? Or?
Yeah, sure. So basically we've got our pump. It's a 12 volt pump. The model number, the 70, stands for litres per hour of fresh water it can make. So the motor's basically driving this pump in here. It's got the membranes attached underneath, so this is all one unit and you just bolt it down.
And that's how it comes to. That's straight out of the box. So straight out of the box we just got that one kind of unit we need to bolt down, which is both the motor, the pump and the membranes. And then off to our left we've got the pre-filters as well.
So one of them is to filter seawater. While the pump is making water, seawater comes up through this pump, filter, sorry.
We forgot to mention at the time the carbon filter is for freshwater flushing the system after it's been used.
John mentioned that it is a 12 volt system, and for us that was actually quite important, because if we went with 240 volt and we had a problem with our 240 volt inverter, then we would be kind of screwed for fresh water. But because it's 12 volt, we've got solar panels that can make 12 volts power. We've got alternators on the main engine make 12 volts power, so it gives us a lot more options in that regard. Why are we installing a Watermaker in the middle of the saloon? The long and the short of it is that's where the original one was mounted, and we are replacing an existing Watermaker that was here previously. There's already power cables run to this spot. There's already all of the plumbing run to it. What else do we get with the kit, John?
So a couple other parts. There's the small pump that just you can bolt on somewhere. It's rubber mounted. So this provides the raw seawater to the main filters. There's a diverter valve. So when you run the Watermaker, we can test the water just by going out to our test hose, and then once it's shown that it's nice water, it tastes alright, divert it to the tank on the other side. So that'll fill the tank up. The other thing is our pressure gauge. This is pretty important to make sure that the Watermaker is running correctly, and it comes with these high pressure hoses. They just push fit into there. They're quick fits, so nice and easy.
Now, in addition to the parts that it comes with, we do need extra parts. So this is going to be obviously by vessel. Firstly, we've got the sea strainer. So we're going to go from our Seacock, which is currently set up with a 3/4 inch hose, and then we've got a 3/4 inch to 16mm adapter. Bit of 16mm hose is going to go to the sea strainer, and then from there we've got another piece of 16mm hose which goes into the lift pump and into the Watermaker itself. We've got on the flushing side, there's got a 13mm T. There's going to be some 13mm hose comes back to the Watermaker, and we're going to need a 13mm to 16mm adapter so that we can adapt it into the carbon filter, which we saw just before. For the water, the salt water that doesn't go through the membrane, we've got another 16mm to 3/4 adapter. So as it happens, this boat, the hose going up overboard is a 3/4 inch hose. And then we've got this fitting which goes from the output of the Watermaker, the freshwater output, and that's going to go, that fitting goes into there and then goes to a 13mm, which again is what is plumbed into the tank distribution system, which in our boat is this kind of series of valves. Yeah, one other thing I forgot, which is electrical cable. So we're running about 6 meters. I didn't quite get the cable size which they recommended. I've got an 8mm square cable, and there's 6 meters that I figure we can go from the switchboard through to the Watermaker in about 6 meters. Should be a little bit less than that. Current draw is about 20 amps, needs to have a 30 amp fuse on it. So yeah, 8mm squared should be pretty much overkill for what we're asking of it. It should be a hand model.
Lush.
Lush, it's like a forest.
John got started running the electrical cables underneath the saloon floor, while I glued 2 pieces of wood to the inside of the box so that we could mount the various pieces of equipment to it. These were glued just with some epoxy resin and filler, and then you can see me here sealing it afterwards to stop the moisture from getting in, again with some epoxy resin and a little bit of filler.
So this is the flow out selector, so it goes either to the tank or to the sampling system, and you can see the valve body doesn't actually have mounting, so we can't put this up against the wall. It's only got its mounting screw holes on the same side as the valve. I've got this junction box, Dita junction box from Bunnings, and it does have pop-out slots, and I just extended these all the way to this surface, and how that works out is that goes onto there, the back plate can go onto there, we can screw obviously the back plate to the wall, and then we've got our selector. Turn that valve as we see fit. So I'm just putting on the final part. We actually have power going to it, we just haven't hit that switch yet. Actually, we probably should have checked the relay. Put that into there, and now it's time to kick her in the guts, Trev.
Are we sure?
Yeah. Come on, flick the switch. I'm so excited.
Here we go.
Oh shit. What's
That was minor disappointment.
my money, John, is on the relay wiring. I hate to say it, but money's on the relay wiring.
Mine's not. Main power is that one. Oh.
No fuse?
No fuse.
Okay, John's putting the fuse in now.
Because that's always a good idea.
It's not turned on at the moment. Whilst he's doing that, let's enjoy the excellent fuse, the valve body housing we've got there. The Dita junction electrical box.
Kick her in the guts.
Kick her in the guts, Trev! Hooray! Oh shit, that's, yeah, right on there, I need to watch over that. It's pretty quiet.
Rapid or what?
I guess it's not running at high pressure yet, but... Goes. Okay, yeah.
Disappear.
Yeah. It's either somewhere between... I can't even say. Because they're like og and 008 and og. But no, it's actually... oh, actually, is that... sorry, that's just over 700. So that's running just over 700. So this is our current flow at the moment is upside down, 22 point something, 23, it was going 24 there for a second. So just over 20 amps. Okay, so we've got our 250ml test. You ready? Marked, get set, go. So this will allow us to say how much water we are generating for that 23 odd amp draw. Say when? Go then?
Yep.
14 seconds for 250 mils. I'll work that out and put it on screen. So, cheers.
Yes.
First water maker to create beer. Well, we're having a beer to celebrate.
You could make beer out of it.
But I guess, first thing we do have to do is to really drink some of our
water.
Made water.
Minus desalinated seawater.
Doesn't really taste like anything. Probably should have had this before the beer, to be honest.
Maybe.
Yeah. It does not taste like beer.
Not tasting like anything's a good thing.
Yeah, that's probably a good shout. And it really, really has no taste at all. There's nothing there at all. So,
no floaties, no nothing.
And obviously, as we're sitting here, it's running beneath you, and it's there. We can hear it, but it's not at all impeding on our conversation or anything. It's quiet enough that it's still a pleasant environment.
And it's not a annoying noise. It's not like the neighbour's lawnmower.
A little bit over 60 litres per hour at 23 amps, and that is at a reasonably, well, not a high seawater temperature. So obviously, as we get warmer seawater, we'll be having a higher output. What kind of things would you do differently next time, John?
I think at the moment the mounting, the feet, we had to sort of work out how to mount it, because the whole unit slides on the feet if they're not quite at the outside.
Yeah.
But I think not hard to get around that for the majority of installs.
Yep.
The wiring's pretty simple. We did think about putting the lift pump on a separate switch, but it seems fine the way it is.
Yeah, I'm not gonna. I don't think we should put the lift pump on a separate switch, but I have ordered. I didn't mention this to you earlier. I have ordered an hour meter.
Yes.
So that's gonna be coming in from RS. So I think next time we would get a bigger box so that we can fit the hour meter in it too. So bigger box for the switch. If I was to do it again, I would actually put a breaker into the DC side of the boat. But obviously that's another. The DC distribution is another kind of kettle of fish, and obviously it's going to vary boat to boat as well.
Yeah.
But then you could just have a straight switch down in this box instead of having to go through a relay type of thing too.
And the other thing potentially would be a flow meter, so that because normally it's not running in straight into cups in the galley, it's running into a tank, so you don't actually know how much is being made. So it would be interesting to have a flow meter and just keep an eye on everything. So
That's a good call. I would be inclined to more put it onto a salinity meter first.
Yeah.
And then, because if you had it plumbed up and with a salinity meter, then you could kind of have the other side of the salinity outlet, just going to the waste overboard instead of having to come out of that whole area. And we could actually program an in-pipe bus system to do it. So.
Yeah, there's it's great in its simplicity, and you could get carried away adding all sorts of things to it that aren't strictly necessary.
I think if one of the things I'd change next time is I think I've used the wrong type of hose on the low pressure side of the seawater, and I think we risk that 16 mil collapsing. I'd also keep it 3/4 inch all the way through to that lift pump, because I'm pretty sure that lift pump's actually a 3/4 inch fitting on it. It was a bastard to get the 16 mil hose onto it.